Hey fam, welcome back once again to JJ's PC Build. You know who it is, your boy JJ. Well, I'm going to tell you what we're going to have our video on today. Our video is going to be on graphic card safety. No, I'm just kidding. It's going to be on the RTX 4090 Nvidia card, the connector. I want you to stick around. We're going to roll this B-roll. And here we go. Do enjoy yourself right here on JJ's PC Builds. Alrighty, welcome back. Alright, I've been watching a couple reviews, and believe it or not, I'm not the kind of man that doesn't watch other people's reviews. Okay, I watch everybody's reviews. If it pops up on my YouTube, I watch it. And I give them a thumbs up and everything else. Just to let you all know, I do that. Doesn't matter what reviewer it is. I don't leave no bad ill ties. Everybody deserves the respect, and I give you all the respect. But today I did review a couple reviewers reviewing the RTX 4090 connector. The reason is I don't have the Nvidia 4090 in front of me. Okay, I didn't get one, and I apologize for that. I can't afford it. I'm gonna be honest with you, I can't afford it. Because $1,600, you know, I mean, where am I going to come up with that kind of money? I'm just, you know, when I become where I'm rich and everything else, and I can afford it, then I can get it. Until then, I have to work my way up. To getting to where I can afford things for this channel. Okay, I'm doing this absolutely bankrollless. So basically, I'm not funded for this. This is all me, and you know, I'm just doing this and trying to build this to where I can fund this. Just to let you know, we're working towards that in time. But in the meantime, all I can do is do my thoughts and opinions on a couple things. But anyway, getting back to, well, before we get back to it, make sure you like and subscribe to videos. If you like my videos, please put a like on them. You know, it doesn't hurt, it doesn't cost anything to put a like on. As well as subscribing. Doesn't cost you anything to subscribe. I'm not charging anybody anything for you to subscribe to my channel. And I'm not charging you anything to watch my videos from the beginning to the end. So, you know, if we get 1,000 subscribers, we get 4,000 watch hours, then I can move up to bigger and better things. But I can't do that if I'm stuck at, you know, this rut to where all these rules and stipulations and everything else, which in my books are crap, you know. But anyway, that's for another video. We'll do a complete video on that, so stick around for that and I will tell you about it, my thoughts on that. But anyway, let's get back to what we're going to have our discussion about. Okay, back to it. I watched a couple of videos. I watched J2 Cents videos. That's one. And I watched Gamer Nexus. They had some good insight about the connections, you know, the connectors to the video cards, looking at that. And, you know, looking at the inside of it from electrical my kind of understanding from electrical standpoint, which I do have electrical standpoint on this because I worked on electronics, rebuilding and everything for many of years. I've worked on computers for many of years. I've worked on stereo and audio equipment as well for many of years. I did all this one little thing. All this in one big ball. But looking at the inside of the connectors, I can see a couple flaws. From what I've seen on the videos and the presentation, I see a couple flaws. Now, for me to tell you where the flaws are, one, the flaws is in between the plate that you solder the wires onto and the bridge that goes in between the two and that goes to the pin structure. Okay, the pin structure is wrong. You don't put a female side on the connector itself. You put a solid pin connector. It should have been a solid male connector on the pull-out connection. On the video card should have been the female side. Okay, not putting the male side on the video card. That's not good. That's just basically cheaping out on the connector itself, and that's basically what happened. They cheaped out on the connector. They probably made the end of that connector 3D printed to cheap out even more on it, and instead of using a Teflon connector itself. Teflon doesn't burn. Okay, if you would have got Teflon wires with the Teflon connector and made that inside that bridge between the plate you solder on and the pin itself, and made it a solid pin, and then made the video card a female pin, then you would never had this problem. No, you cheaped out and you did the opposite, and there it is. Doesn't matter what kind of wire you're using. Well, it does matter. The wire that you're using is low voltage wire, or low amperage wire, not voltage, amperage. Because if you do the voltage to the amperage, you think running a 130, 150 volt wire is going to carry 30 amps. Possible. Everybody knows you're running 12 volts. And 12 volts, and you pull 60 amps off of 12 volts, is different from pulling 150 volts at 30 amps. Do your math. Do the voltage times the amperage to get your wattage. Okay? Then you got what they call resistance. Now you got a resistance built up between the plate where that connector is and the bridge that goes to the pin. Now that bridge is where you got the resistance. Is because the bridge is too thin going from the plate to the pin, and it's causing the bridge to turn red. It's causing the bridge to melt when you pull amperage through that bridge. Now, if you don't know what I'm talking about, it's very common sense. Pull the connector apart, cut it right down the middle all the way through from the front side to the back side, and right in between the hot and the ground. And there's that little bridge plate. That little flat piece that you got going through there is too thin. You got it rated at, you got each one of those pins rated at maybe 15 amps. Each one of them you got rated at 15 amps. They should be rated at 60 amps. Between the wire and connecting that wire onto the connector, that bridge that goes in between the flat plate and that pin, and the pin itself should be rated at 60 amps. You should have amp tested the connector itself from the beginning point to the end of the pin point to see how much amperage it actually holds up to. And I guarantee, if I were to take an amp meter for an automotive vehicle, put it on one side, and have it draw that percentage, that 400, 600 watts through that pin, I bet you each one of those pins will melt at 600 watts. Each one of the pins will melt at 600 watts. So your variance is in between. You're trying to run one power out of your power supply, which is 12 volts. One power. Not 5, not 6, not 8 different hot sides. If you had 8 different hot sides in your power supply, 8 different, then you would have 8 different variances. That means you would have 8 different power transistors. That means you would have 8 different, 8 different ecosystems. And the transformer would have 8 wires coming out of it for each one of the legs. That's not how a power supply works. Power supply has one 12 volt section. That means every wire that's coming out of, that's 12 volts, out of that power supply is from one power source. And you're breaking that point into 15, 16 different points to 16 different, maybe 15, 16 different wires. And you could look inside your power supply. Look very carefully. Look how big and thick. Big and thick. The beginning point inside that power supply is on the 12 volt side. And you got all those wires bridged into one source. One source. Now, don't take my word for it. Look at it yourself. But anyway, I'm not going to make this a forever video on how power supplies work and everything else. If you want to know how a power supply works, get your multimeter out. Start there. Start at the source. See how much power you're pulling off of your 12 volt side. Amp test it. Make sure it's amp rated. And if you can pull 60 amps off your power supply, which it better be rated at 850, 900 watts, just to let you know, if you want to pull 60 amps. Just for say. These power supplies are not rated like an automotive vehicle. Toward 12 volt side, you get a lot more amps. You get 2,000 to 4,000 to 6,000 amps. You can get maybe 4. I know some people are pulling maybe close to 1,200 amps. There's no way that you're going to get a power supply that's for a PC pulling 1,200 amps. That's about maybe 12,000 watts. I don't think you're going to use that. For a computer, if you pull 12,000 watts for a computer, you might as well hook it up to your car. Just to let you know. It'd be a lot cheaper and easier just to hook it to your car. But anyway, like I said, I think the best videos to watch are from J2 Sense and from Gamers Nexus. They did some testing. I'll leave the links in the description down below for you all. Those are the best to go to because they went inside of how these connectors are, what's going on with these connectors. So if you're looking for that information, I'll point you in that direction. But when I get my hands on the connector, get my hands on the card itself, when I can afford it, I will get the card, I promise you, and I will test it, and I'll beat the crap out of the card. Just to let you know, I will test it upside down and beat the crap out of it. And I'm not easy on a PC. I'm the hardest you can ever think of being on a PC. I mean, I ran my other PC, I ran that 2 years solid, 24/7. On one game. I stayed online 24/7 for 2 years with that PC, and it never broke down. Believe that. That's how hard I am on a PC, and on top of the daily usage and everything else. So when I tell you I test something, I test it, and I keep it testing, and I keep it rolling for at least a year, and I'll update you every time. So just to let you know, this new PC that I'm building up slowly, as soon as I get the graphics card for it, it doesn't really need a graphics card. I just want one just to see what it's like to have a graphics card, for this PC. But anyway, like and subscribe. You like the video, make sure you subscribe. That way you get the most updated videos I put out daily. So we're going to go ahead and jump out of here. This is JJ, your boy. We will see you on the next video.